Welcome to Lab 5 Interfacing Piezo Buzzers with Arduino Uno board. In this lab, you will learn how to interface a piezo buzzer with an Arduino Uno board to generate different tones. The objectives of this lab are as follows. Firstly, you'll need Arduino Uno hardware and Arduino software version 1.05 or newer. You'll engage in tasks such as writing, compiling, downloading, and testing programs to control LEDs using the digital outputs on the Arduino Uno. Additionally, you'll interface with various devices such as LEDs, switches, and piezo buzzers. For the materials, you'll need a breadboard with an Arduino Uno, a 120V AC to 12 VDC adapter 1000 mA, a digital multimeter, 220 ohm resistors, and of course, LEDs and piezo buzzers. A piezoelectric speaker operates by harnessing the piezoelectric effect to produce sound. This effect generates initial mechanical motion when a voltage is applied to a piezoelectric material. Subsequently, this motion is usually transformed into audible sound using diaphragms and resonators. Unlike other speaker types, piezoelectric speakers are straightforward to operate. They can even be directly connected to TTL outputs, although using more advanced drivers can enhance TENS sound intensity. They typically perform effectively within the frequency range of 1 to 5 kHz, and in specialized applications they can operate up to 100 kHz GN ultrasound applications. For this particular specification, buzzer type 8 ohms impedance with a power rating of 0.5 W, rated voltage 1.5 VDC, rated current not exceeding 60 mA, output sound pressure level of 85 dB, resonance frequency 2048 Hz, operating temperature ranges from -20 to 45 degrees Celsius. Step 1. Establish a connection between the Arduino Uno R3 compatible board, a breadboard, and a passive buzzer using jumper wires. The illustration below demonstrates that the positive terminal of the buzzer links to the Uno's digital I/O pin 7, while the negative terminal connects to the ground. Step 2. Develop the test code and access it using Arduino software or IDE. Step 3. Ensure that you have selected the correct board and its corresponding port. For this lab exercise, the Arduino Uno board is utilized. Step 4. Proceed to upload the test code to your Arduino. Now, let's proceed to the eLab tasks. Program 1 is to compose a code using Arduino's Integrated Development Environment IDE to render a melody comprising a minimum of 30 musical notes. Configure your program to initiate a sequential light display employing 8 LED lights following the melody for added visual impact. Replay the melody at an accelerated pace, around 75–80% of its original duration, accompanied by another rapid light sequence. Implementing blinking light patterns or running lights throughout the melody rendition is recommended. The following table lists the frequencies of each key on a piano keyboard. Here is an example of piano keynotes. Create a circuit diagram using Tinkercad or Fritzing software, then execute the program to ensure its proper functioning. Demonstrate the program's operation to the instructor and produce a video demonstration for your YouTube channel. Include the video's URL link and a corresponding QR code in your documentation for accessibility. Capture a screenshot of the finalized circuit and save and print the program code for reference. Program 2. Arduino Jukebox. Develop and craft a musical jukebox, which functions as a menu-driven system accessible via the serial monitor screen. This system offers a selection of 6 preschool rhyme songs, or any 6 songs of your preference. By utilizing switches, users can opt for a song to be played by the Arduino. Additionally, implement a running light pattern synchronized with each song, illuminating in tandem with the song being played. Here is the Arduino Jukebox lineup. 1. Twinkle Twinkle Little Star. 2. Ba Ba Black Sheep. 3. London Bridge is Falling. 4. 5 Little Ducks. 5 If You're Happy and You Know It. 6. Rain Rain Go Away. Then an input to pick a song. Create the circuit diagram using Tinkercad or Fritzing software and confirm that the program runs correctly. Produce a video demonstration of this program and upload it to your YouTube channel. Include the URL link of the video and a corresponding QR code in your documentation for convenient viewing. Capture a screenshot of the finalized circuit and present it. Demonstrate the program's proper operation to the instructor and save and print the program code. Create the third program titled Arduino Piano. Establish connections for 8 button switches representing the notes do, re, mi, fa. Develop a program enabling users to play a song through the button switches and buzzer connected to the Arduino board, simulating a piano. Ensure the program runs smoothly. Design the circuit schematic using Tinkercad or Fritzing software. Produce a video demonstration of the program and upload it to your YouTube channel. Provide the URL link of the video and a matching QR code for easy access in your documentation. Insert a screen snapshot of the final running circuit. Demonstrate the program's operation to the instructor. Lastly, save and print the program. Program 4. Switch-controlled siren running light. Connect a 3 red-colored LEDs with 3 limiting resistors and 3 colored LEDs with 3 limiting resistors and 3 blue-colored LEDs with 3 limiting resistors to the Arduino board via the breadboard. Develop a program to create a switched color siren player, controlled by 5 toggle switch tactile push-button switches. Incorporate 5 distinct siren tones, each linked to one of the switches. Each tone should be accompanied by a unique running light pattern. Ensure the program runs smoothly and functions as intended. Generate a video demonstration showcasing this program and upload it to your YouTube channel. Subsequently, include the URL link to this video in your documentation, along with a corresponding QR code for convenient access. Design the circuit diagram using Tinkercad or Fritzing software. Capture a screenshot of the finalized circuit in operation. Present the program's proper functionality. That concludes the presentation. Thank you for listening.